All right, yesterday we talked about parallel lines and transversals. What we're going to do today, kind of the same thing, but we're going to give a relationship between them, okay, numerically, okay? So, what's equal to what? Maybe some things are supplementary, maybe some things are complementary, maybe whatever. All right, let's do this. All right, so what I'm going to do is try to draw a straight line here. Do it this way. All right, there we go. All right, and we got another one right here. Now remember yesterday when we talked about this, we did these two lines. We did two lines in a transversal. Oh come on. We uh, we made them obviously not parallel to each other. Do you remember yesterday we did that transversal? They were obviously not parallel to each other, but the names still work. Today what we're going to do is we're going to actually deal with parallel lines. So how do I know they're parallel? Well, if I put an arrow right here and an arrow right here, that means these two lines are parallel to each other. So there's no doubt that they're parallel if they tell you, okay? If they give you the, is my elbow hitting that screen? Probably is, isn't it? All right. So these two lines are parallel because they told you. Now they could have, labeled the lines and up here somewhere said, line L is parallel to line M or something like that, or line A is parallel to line B. But I just put the little arrows there just to show that they are parallel to each other. All right. So what do I need now? I need something that crosses them. What do we call that thing right there? Transversal. Good. All right. So that's our transversal, and here's our parallel lines, and we've got all these angles in here. Now let's talk about this. Let's do the corresponding angles first. I'll just shorthand it. I always just put CORR. Is that okay? You understand what that means? So the corresponding angles. We have a theorem, or a postulate actually. This is called a postulate. Now I'm not going to have you memorize the numbers for these postulates. And we have other things called theorems. A postulate is basically just a rule. It's just something that they tell you is true. All right, so we don't call it a law, we don't call it a rule, we call it a postulate. Now, a postulate is something that is accepted without proof. Now, remember we skipped chapter 2? They started talking a little bit about proof, so I may throw some things in here that they might have covered in chapter 2 that we kind of skipped over, okay? But a postulate is something that is accepted without proof. If they just tell you that this is true, we just accept the fact that it's true. You okay with that? So that's a postulate. Now a theorem, on the other hand, we're going to be writing down a few theorems. A theorem must be proven. All right, so a postulate does not have to be proven, and we'll talk more about proving things a little bit later, but for right now, just understand that a postulate is just an accepted fact. All right, they tell it to us, and we just believe it. We don't have to prove it to anybody. You with me? All right, so that's a postulate. So this first one right here is a postulate. It's about corresponding angles. Well, the postulate says, now, they are numbered in the book. They number this postulate 3-1. I do not want you to memorize these by numbers. I know some geometry teachers, they have you memorize the number of the postulate, and they have you memorize exactly what the postulate says. I think, personally, it's a waste of time. Because if you go to another book, this is called postulate 3-1. Why do you think they call it postulate 3-1? Do you think this postulate is named 3-1 all across the board, no matter what school, no matter what book you do? No. Why do you think they call this 3-1, Jacob? What do you think? Why do you think they call it? Why the 3? Because it's chapter 3, isn't it? It's chapter 3. Now this is section 3-2, and the postulate is 3-1, but what do you think? It's chapter 3. Which postulate is it? It's the first postulate. That's right. Okay, so it's just chapter 3, and it's our first postulate. Is this postulate always in chapter 3 in every single math book ever? No, it's not. All right, so we don't memorize it by the numbers. You okay with that? And I know some geometry teachers that have their students do that, and I think that's weird that they do that. But anyway, I don't. Just know what it says. All right, just know how to use it and what it says. I'm not even going to say, there won't ever be a quiz or a test where I say, all right, list the first 4 postulates, or tell me what postulate 3-1 says. I will not ever say that. You understand? But that doesn't mean you don't know what it means. You need to still know what it means. The corresponding angles. So let's put some corresponding angles in here. So I tell you what, let's just list all of them, just like we did yesterday. We'll number them exactly the same way that we did yesterday. All right, so those are all our angles that are formed, and the corresponding angles, what are they? 1 and what? 5, 2n, 6, 3n, 4n. All right, those are the corresponding angles. Now, we didn't learn anything yesterday about whether they're equal to each other or not, but here's what the postulate says. If you have two parallel lines, so if you have two parallel lines cut by a transversal, do we have that situation here? Yeah, we do. Then, guess what must be true? The corresponding angles, what do you think? Just eyeballing it, what do you think is true about angle 1 and angle 5? Yeah, they look equal to each other, don't they? And they absolutely are. Okay, they are equal to each other. So 1 and 5 are equal to each other. So what's true about the corresponding angles? If you have parallel lines, okay, that's a big if. You got to have parallel lines. Remember the picture yesterday? The lines were not parallel. So did angle 1 and 5 yesterday necessarily equal each other? No, not if they weren't parallel. They got to be parallel lines for this to be true. So if you have parallel lines, the corresponding angles are what? Equal, right? Okay, so I'm going to put the corresponding angles are equal. Or I think they use the word congruent. All right, it's basically, as far as we're concerned, it's the same thing. Is that all right? So the corresponding angles are equal. So now let's go a step beyond what we did yesterday. All we did yesterday for the corresponding angles were just list which ones were corresponding angles. Now we can go a little bit further than that, can't we? So now I'm not just going to say that angle 1 and 5 are corresponding angles. What can I say? I can say angle 1 is what? Equal to what? Angle 5. You follow me? All right, so 1 and 5 are actually equal to each other. Give me some more. Angle 2. It's equal to angle 6. Angle 3, what? Is equal to angle 7. And what? Angle 4 is equal to angle 8. All right? That's different than what we said yesterday, isn't it? Yesterday, all we did was say, okay, these are the corresponding angles. We didn't say anything about them. But now today, in this lesson, we say that those angles are equal to each other. Now, why is that true? Why does angle 1 equal angle 5? Well, because what? The postulate says, all right? Because corresponding angles are congruent. That would be your reason. I'm trying to lead you into some things as far as doing proofs a little bit later on. All right, again, we skipped chapter 2, so there's some things I'm going to start throwing in there a little bit that were covered in chapter 2. All right, but I just don't want to take the time to do that whole entire chapter. But if I asked you why, give me a reason why 1 is equal to 5, what would you write down for your reason? What if I said why? Why is angle 1 equal to angle 5? Well, because the postulate says that what? That corresponding angles are equal. Now, it actually goes a little further. I'm okay with you just saying that corresponding angles are equal, and we'll just shorthand it just like I did there. Corresponding angles are what? Equal, or congruent. I'll put congruent. That would be your reason right there. All right, that's your statement that 1 is equal to 5. This is your reason that corresponding angles are congruent. I'm just slowly introducing some things that you're going to need to know for proofs. All right, so pay attention to these things. You may think that, oh, he's just saying all this stuff. Okay, I know they're equal to each other. That's all I care about. I don't care about why, but you're going to need to. Eventually, you're going to need to care why they are equal to each other. You with me on this? All right, so make sure you understand why. Same thing, same reason for all of these. Why is angle 2 and angle 6 equal? Because they're what? Well, they're congruent. For what reason? Why are they congruent? Because what? Because the postulate says that what? The corresponding angles are congruent, right? See, that's the reason right there. Why? Corresponding angles are equal. Why are 2 and 6 equal? Give me a reason. No, right here. Come on. Look, here's the reason. It says why, and then I wrote the reason. Okay, so why are 2 and 6 equal? Because corresponding angles are congruent. Why are 3 and 7 equal to each other? Because corresponding angles are congruent. One more time. Why are 4 and 8 equal to each other? Because corresponding angles are congruent. Okay, you get that? I want to make sure that I hammer that through. That's the reason. We don't just say because the postulate said so. We don't say because postulate 3-1. In fact, I don't even care. I would have never known that's postulate 3-1 unless I looked in the book and I saw that. All right, and I've taught this for several years. So, well, I've taught this a whole lot of years, but not out of this book. That's the reason. The corresponding angles are congruent. That's the reason for any book that you look through. Doesn't matter, all right? Doesn't matter what number postulate is or anything like that. That's the reason why those angles are equal, and that's important. You may not think so right now. You may think this is just kind of dumb stuff, but there's definitely a good reason to understand why that they're equal. Let's do some more. What was another type of angle we talked about? Yeah, alternate, and I'll shorthand this too. Alternate interior angles. All right. Alternate interior angles. Now let's list them first. So what would one pair of alternate interior angles be? What do you think? Ricky, do you see alternate interior angles? Which ones would be alternate interior? Just give me one pair. 3 and 5? Are they alternate? Now they are interior angles. You got that part right. Remember to be alternate, they got to be completely opposite. So Nico, what'd you say? 3 and 6. Okay, 3 and 6. So you see 3 and 5 are on the same side of the transversal. Alternate means they're completely opposite. All right? If you flipped it around, it would be on the complete opposite side. So 3 and what? 6. Give me the other pair now. 4 and 5. Do you see it? Okay, so 3 and 6 would be alternate interior, and 4 and 6 would be alternate interior. Everybody with me? What did I say? Did I say something else? Sorry, 4 and 5. I pointed to 5 and I said 6, right? 4 and 5. You got it? Look at those angles. Look at 3 and 6. That kind of looks like a acute angle, doesn't it? And look at 6. That looks like an acute angle. Guess what's true about those two? They are. They're equal to each other. Okay, they're both acute, but they're also equal to each other. So let's list the alternate interior angles. There's not as many pairs, but what would it be? Angle 3 equal angle 6. Okay, so they're actually equal to each other this time. Yesterday, again, all we did was just tell which ones were alternate interior angles. Today, we're saying that they're equal to each other. Give me the other one. Angle 4 equals angle 5. All right? That's pretty important. We're going to use this a lot, not just in this chapter, not just in this section. There's going to be times where later on in the book, in a completely different chapter, we're going to have to know this stuff. Yeah. Yep, we're going to do that in a second. We're going to list all the stuff that are equal to each other. Absolutely. All right. All right, so what's the other type of angle we talked about? Alternate exterior angles. Let's throw that down right here. Alternate exterior. Exterior means on the outside, right? Interior means on the inside. Alternate exterior angles. Now, guess what's true about the alternate exterior angles? Let's list them first. Angle 1 and what? 8. That's right. See how they're completely opposite each other on different sides of the transversals? One's way up here, one's way down here. You get it? So alternate exterior angles. Look at that. That's obtuse, and 8's obtuse as well. So what do you think is true about those two angles? They're equal as well. So let's list them. So angle 1 equals angle 8. And what's the other exterior? Alternate. Good. Angle 2 equals angle 7. So those are alternate exterior angles. All right? It's pretty easy to see, right? Looks like everything's equal there, doesn't it? All right, but not everything. Look at 1 and 3. They're obviously not equal to each other. So not all the angles are equal to each other, right? But let's list one more thing. What's the other type of angle we talked about yesterday? Starts with a C. I already did corresponding. Consecutive. Consecutive. Again, I'm just going to shorthand it like this. You need to know the word. If you forget the word, jot it down. But it's consecutive, what? Interior angles. Now, what do you think is true about those? Are they equal to each other?
No.
Nah, look at it, because look. Yep, you're right. 3 and 5 are consecutive interior angles, but is there any way that they're going to be equal to each other? There's no way, because what kind of an angle is angle 3? It's an acute. Look at angle 5.
Obtuse.
Is there any way an acute angle could equal an obtuse angle? There's no way. So they're not equal to each other, but make a guess. They add up to 180, exactly. So what word do we use? They're supplementary, right? They're supplementary. They're not a linear pair, are they? Because they're not two angles that form a straight line, but they are two angles that add up to 180 degrees. What would a linear pair be? Angle 3 and what? 3 and 1 or 3 and 4. They would be a linear pair, but 3 and 5, even though they're still supplementary, they're consecutive interior angles. You see it? They're interior. They're consecutive, which means one right after the other. And they're interior. And they're on the same side of the transversal. Oh, I am. Let's list them real quick. I'm not even going to change colors. So angle 3 is not equal to, but is what? Is supplementary to what? Angle 3 and what? 5. They're consecutive angles. And then angle 4 is, I'll just shorten this because I'm running out of time, is supplementary to what? Angle 6. Okay, they're supplementary. They're not equal to each other. That's an ugly box. That's okay. Let's go on to the next video.